you have what's called the zero product property. All right. So the zero product property, what this does is it says that if you have, we're just going to start with two factors, but it can be more. If you have two or more factors that are multiplied together to get zero, that the only way that this is going to work is if each individual factor is considered the possibility of a zero. So either the first factor could be zero or the second factor could be zero. You have to decide what they are, all right, which one is which. So what we're going to be doing is, because we're solving by factoring, is we are not going to have individual factors necessarily like that. We could have like little monomial factors, but a lot of times we're going to have binomial factors. And so everything that we're going to do today is going to say solve, which is different than what we did in the last section, because in the last section you were just factoring expressions, right? There was no like actual equal sign in there. Now you have to solve. All right. So you have an equation now. All right. So everything you do has to be kept in terms of an equation. There must always be an equal sign and always something on the other side. And so your job is to look at these two terms and see what they have in common and factor out what they have in common. And so they both have a 2 and an x in common. And what's left would be x minus 1. And that product is equal to 0. So all I'm doing is manipulating the left-hand side and factoring out what they have. I did it again. Forgot my 2. Sorry. Should be 2. And again, I like to double check it because I just multiplied through and realized that my product, I had forgotten my 2 here. And so now this is set up actually in the form of the zero product property. Either the first factor has to be equal to 0 or the second factor has to be equal to 0. That's the only way that this is a true statement. And so you're going to set each individual factor, whether it's a monomial factor on the outside or a binomial factor, equal to 0 and solve. I mean, if I just divide by 2, it just shows me that x equals 0 is one of the options. And then I need to solve a two-step equation over here, which we can just move the 1 over. And if you're okay with not showing the dividing by 2, you can divide by 2 mentally. And so there are two solutions to this equation. There's two values for x that will make the original true. And usually you write this in set notation. So something like x is equal to, and we use these little set brackets and show all of the values inside a set, separating them by commas to show all of the values that make a true statement belong in that set. And so if you have just two terms, all right, you're going to look to see if you can just factor out a GCF first and then go from there. Right. Really what this means, we haven't really talked much about it, but what's going to end up happening is that we're going to get to graphing. And these values right here, where x is 0 and x is 1/2, these are going to be zeros or roots to a polynomial that's going to look like this. And so solving equations by factoring or solving using the zero product property will tell us our zeros. They tell us what these factors are. They tell us where they cross this x-axis. And so that's what we want to be able to do. So we're going to start off today with just doing this work, but that's where we're going to get to. All right, so if you have more than two terms, now you have to use all of your factoring skills and strategies to figure out what you're going to do in terms of the factoring. So for example, x squared minus 11x plus 24. We had problems exactly like that without the equals 0 part, where you were just factoring, like on your last review and your last test. And so now you got to go through all of those like strategies for factoring that we did last time. And you can look at it and you see, because there's a 1 here, you don't necessarily have to do the area box. You can go off to the side here and you can look for factors of 24 that add up to be negative 11. So that product and sum we were doing before. So you can use an area box if you like, or you can do the shortcut that we did before. And so if I'm looking for values that multiply to get 24 add up to be negative 11, they have to be the same sign. And I'm just going to like double check that minus 3 minus 8 is negative 11, and they multiply to be positive 24 before I move on. So again, now I've factored, still set equal to 0. Now you can solve. Either the x minus 3 factor has to be equal to 0, or the x minus 8 factor has to be equal to 0. So once you set up using the zero product property right here, you can do the mental math to solve for the values that you need to be your x values. But I want you to write your final answers in this set notation. So that way this is what I want your answer to look like. And it's because your assignment is going to do the same thing. So I want you to do the same thing in your notes as you're going to do on your assignment. Okay. It does not matter what order the values are on the inside. I tend to put them in numerical order, but it doesn't matter as long as they're in that set. Order doesn't matter. So you get some ones where you're going to have to, it's almost identical to your exam that you did before. All right, for example, 4x cubed minus 6x squared minus 10x equals 0. So think about the one that you had on your test, all right, where I told you better check to see if you can factor any kind of GCF out first. That's going to be your first goal, is you need to look to see if they have any numbers in common. And I can factor out a 2. And they all have an x in common. And so that's what I'm going to do first, is factor out the 2x and then see what's left over. I have a 2x squared minus 3x minus 5 that's left over. And again, you still have to keep this equal to 0 because you have to continue having an equation. You can't all of a sudden make it disappear. There has to still be an equation. And now you need to go off to the side somehow, and you need to factor that. And now since your a is not 1, something other than 1, now you probably have to do the area box. So I'm going to kind of come over here real quick and make my area box, because that's how I know how to factor these. As far as it's going to go. I can go like that. I guess I can go that way. I can try writing like that. All right, so you have to remember that this 2x that's on the outside here, this 2x is going to stay there. And what I'm trying to do is factor inside the polynomial to get it to look like this. That's my goal. So inside my area boxes, I'm going to put my 2x squared from the polynomial and my minus 5. And this is where I asked you guys before to look for a product going down that gives a negative 10x squared that has a sum of that middle term, which was negative 3x. So again, each of these get an x, otherwise they're not like terms. Two things I can multiply to get negative 10 add up to be a negative 3 is going to be a negative 5 and a positive 2. And you need to make sure that when you multiply these two together, you do have negative 10, but when you add them up, give you negative 3. Otherwise, you're going to be trying to factor something that doesn't work. And then you can factor outwardly what they have in common. Always double check, like remultiply through to make sure that the numbers actually work. And those are your factors. So your first step is always to figure out how can I factor this, and then I want to be able to now use my zero product property. It just happens that now I have three factors. It's like having A times B times C equals 0. So you have three options. Either the 2x has to be equal to 0, the factor on the outside, or the x plus 1, or the 2x minus 5. All three of those need to be set equal to 0 to use your property. When you have a third degree, that tells you that you actually have three possible answers. And I can see I've set 3. So the first one, anything divided by, or 0 divided by anything is just 0. -1. And you can also do this one mentally. If I move the 5 over, it becomes positive divided by 2. So you can either solve the two-step equation like by hand, or you can just do it in your head. Again, now I've got three values for x that are going to go in my set. And again, I don't care if you write them in order. I mean, you can just write them exactly the way you see them. Doesn't matter to me as long as they're all three in there. So like the first one that I showed you, that was a parabola opening up, and the two zeros were the two places it crosses the axis. Right. This is going to be something where the more zeros you have, the more places it crosses. So it's going to be something like this. Not exactly, but that general shape. All right, and so that's what we want to start being able to see, is what is the general shape or the general picture of the parabola or the cubic or whatever it is we're working on, the polynomial, based on some zeros. All right, so that's going to be like our first, kind of like our step for that. The only other kind that you're going to really encounter for the most part for your other last example is a difference of squares. So I need more space, so I'm going to come over here. All right, so a difference of squares, what this is where you have something squared minus something squared, and that this can be factored into what we call conjugates, where the two binomials look exactly the same but with opposite signs. And so kind of like we do when you have an x squared, how an x goes in the front on both of the polynomials. When you have something squared minus something squared, each polynomial gets, or each binomial gets one of those factors with an opposite sign in between. And so the reason we need that is for this last example. And again, most of the examples that I'm doing are what they look like for your homework. So now you've got factors, terms on both sides. Your first goal is to put all of the terms on one side and put this in descending order. So I'm going to put the 0 on the left side, and I'm going to move my 10x squared to the other side, which changes its sign. And I have x to the fourth minus 10x squared plus 9. And you can factor this however you like. If you want to do like an area box, you can totally do an area box. So I'll show you more than one way of doing these, but for today, let's start with the area box. And just because it has a fourth power doesn't mean that you can't do this. So what you want to recognize is that the first term is to the fourth power, the middle term has half the number of powers, and the last term has none. So it's all evens, and that's going to make this work out really nice for us. So I'm going to put my two terms on the sides diagonally, just like I've done before, and look at the product. And then I'm going to look at the sum, which is still going to be the middle term. And the reason why I'm doing this is to use the same strategy as I've done before, where if I have an x to the fourth here, just like I had x squared, I need to have half of them in each box. If I put half of them in each box, then when I go and add up diagonally, they're like terms. So factors of 9 that add up to be negative 10. There's negative 1 and negative 9. And when you factor outwardly on this top row, they don't have any numbers in common, but they have an x squared in common. Yes, ma'am. What do you mean the sign for the 9 didn't change? This stayed the same. All I did was move this term over so that way I can put it in descending order. If you factor out an x squared, you have an x squared left and a minus 9. And then on the bottom row, all you have left is a negative 1. So the issue is going to be that right now, this is what it looks like. You have an x squared minus 9 and an x squared minus 1. And so the problem is going to be is that when you create your two polynomials, you still have two different squares. Those need to be factored using the difference of squares model. And so I'm actually going to need to write some stuff down here because I'm losing space. And so with these, in the first polynomial, when I have x squared minus 9, because that is a perfect square minus a perfect square, I need to create two new binomials where they each get an x, they each get a 3, and then they get opposite signs. So you're splitting them as to what times what gives you that value. Same thing with the x squared minus 1. X squared is a perfect